Today I'm presenting my work for the summer, which is called Digital Booklet. I'm the education and AI intern with the PD team. So before getting into the details, I want to give credit to all the amazing people that we have in our team that have been really helpful with their informative feedback. So our work is basically trying to answer this really simple question, how we are able to increase reusability and reproducibility of the open source code that we have within our organization. And before, to answer that, we have to have these sort of definitions and clear objective what reproducibility is and how is it different from reusability of the open source code. So simply put, reproducibility means that you should have this sort of code that runs again and outputs the same results for you, so other people can work with it, build upon it, and get the same results. There are a couple of basic and simple actions that people usually take to ensure it. Like developers and engineers usually use version control, that is Git or any online sort of platform, GitHub. They have these sort of clear instructions for using them, like setting quick commits, or like when they want to add a feature, they make a pull request and so forth. There are conventions about the repository structure that we see within our deep learning community, meaning that we have our requirements set up, we have the assets, we have different sections, different directories for different features. And we obviously have documentation for the different parts of the code that other people can look up to. And the important part, I guess, for deep learning projects or any sort of related field is the dependency management, as these sort of codes are usually developed with Python, and with Python we always have this sort of a struggle managing different libraries and different versions. But reusability is a bit more than just reproducibility, in terms that not only it should work, but it should also be attractive in a way that other people are drawn to using it again. So to ensure it, the typical ways that usually people use is they provide tutorials, like hands-on stuff. For instance, if you go to this really successful libraries for deep learning like PyTorch or TensorFlow, you see this all sort of amazing content that people have developed and are put out there for the people to go over. And the community engagement is another factor that you should increase, meaning that not only you should provide the attractiveness into your platform, but also should have people who are responsible to handle the issues that people send back to your engineers and developers so that they can improve upon their code. You should have this sort of feedback channels and communication channels with the community. And for some of the projects, you also need to care about continuous integration and continuous deployment, meaning that you want to update your product as soon as you have a new feature added to your code. And you need to make your code in a way that is kind of resource agnostic, meaning that you don't really want to limit your product into any kind of computation or computer resources or like any other resources. And these are actually the very common things that we within our organization take also. So I'm going to give you a walkthrough example of the actions that we typically use at Vector. So this repository is from a bootcamp that we had called forecasting. And looking at the repository, you can see that we obviously have the version control set up. We have really clear and useful structure in the repo. We have the documentation typically in the readme.txt, and we have the set of requirements set up so that people can use it again. And all of those things together ensures the reproducibility of the code that we have. In terms of reusability, we have the community engagements. People have used the repositories and they're giving feedback. We have a couple of demos set up. And in this case, really CI/CD is not applicable here because it's not a software, it's more like a bootcamp. And for resource agnostic, as I said, it's a little bit tricky for deep learning projects because we obviously need high level of computation power, and it's a little bit hard to set up a code that can run in any sort of environment and with any sort of hardware requirements. So with that, my intuition about this sort of packaging and presenting the work that we've done for broad audience, not with technical audience, is that the GitHub repos are optimized for reproducibility, not reusability. So GitHub repos do not really attract the broad audience, although they're really perfect for people with technical backgrounds and they're really familiar with it. So the missing pieces from a GitHub repo that does not attract the broad audience or audience with non-technical background is that you need to provide the resources. People need to have their own resources in terms of computation and hardware. And the idea to compensate for that and improve on that is to link the codes that we have with online platforms that provide the computation resources that we need. The most famous one is like Google Colab, or we can use the resources that Hugging Face or AWS provides. It's not really designed for a broad audience to insist on it because it doesn't really give you a clear pathway how to go through the files, and if you're not comfortable with really working with Git, it might be a little bit difficult to get the most out of the open source code. And yeah, so that order access also is a little bit unclear sometimes if the developers do not really specify it in their documentation. So for the booklet project, we are merging 4 different components, which is the Jupyter book, which is basically a combination of notebooks and documentations that we have compiled in compiled in HTML format, like a static format that you can deploy. We have the resources from Google Colab. We have the GitHub pages, which is a free feature that comes within any repository, and with that you can launch a website for your repository. And we have the GitHub workflows, which are used for continuous integration and continuous deployment. So the module 1 and 3 is ensuring that we can work with a broad audience and ensures the clear order of access. The Google Colab is providing the runtime requirements that we have, and the workflow is just taking care of the CI/CD. To set up a booklet, set up this sort of module that we designed, it's really simple. You just need to add a YAML file within your repository, and that can also be actually automated within an organization, but we didn't have the permission to set it up before finishing up the work. And that is basically a set of code that is going to be triggered when the content of the repository is changed. So to go over the workflow, it branches it makes 2 new branches. One of them is Booklet, one of them is the GitHub pages. GitHub pages is the front that we care about, is like the website, and the Booklet is just the back in which we build the static HTML. And this workflow is triggered whenever a push is made into the repository or like a pull request was made, and that automatically updates everything, meaning that it compiles all the notebooks that we have and it's going to deploy it on the web again. So before going ahead, I'm going to show you the demo that we have. So this is the repository. This is the repository that we have right now, and so this is like a bunch of files, and they're easy to use for non-technical people. But setting up the booklet, it looks like a website. You can launch it on the Colab or Binder and have access again to the code. It has like features that you can use to be able to work with it better. Yeah, so it's just an easier way for non-technical people to use our code. The takeaway that I had from this project was that the Colab hardware have limitations, and to compensate that, we had to modify the source code a bit so that it doesn't have any dependencies on the size of the data set that you use. I got familiar with the MIST Markdown, which provides more user-friendly features when you're building websites and when you're writing notebooks. And I really figured out that automation really matters when you want to maintain a source code or maintain a workshop content. Is really important. As soon as you have a new feature added or a new file added, you would be able to provide it to the broad audience as soon as possible. And for future works, we know that for the vector clusters, we have a Jupyter hub setup. So we're interested to link the prompt to the website to the cluster as well to use the resources that we have. We are interested to make clear guidelines to how to use MIST so that our notebooks can be used not only as the codes that people run, but also as a component that you can launch and use as a setup. And also, we're interested to have a more complicated CCD for the workflow. Maybe we can have tagging or like different features that Git provides to have a more clear and more structured way of publishing the workshops or repositories that we have. I guess that's the gist of it. Yeah, so I'd be happy to answer any questions.
All right, thanks, Sajjad. So I'm curious to what extent the process of deploying a booklet is automated. So I mean, you've showed an example here with the forecasting bootcamp. But obviously, Vector's got a whole bunch of other similar projects. If they wanted to roll out a booklet for those projects, what does that process look like?
Yeah, so right now it's fully automated. So to launch everything, you just have to add this file, like a YAM file within your repository. As soon as you add it, it's going to branch the repository. It's going to set up the config files, the table of contents, and everything. It's going to provide you with a really good template. And you don't really need to add anything to it. So like if you want to change the way that it's presented or exclude some of the contents that you have in the repository, that's where there's any sort of manual work. So I guess simply put, right now it's fully automated. You just need to add the YAM file and it's going to be out there like within a couple of minutes.
Hi, Sajjad. Great presentation. Just a question for you. So have you ever considered maybe doing something a little bit kind of more visual for audiences who maybe this is their first time using kind of a Python notebook, or somebody who may go into these notebooks and feel a little bit overwhelmed knowing where to start? Is there somewhere that users can go to find like instructions and breakdowns on how to use the notebooks and access it?
Oh yeah, so we had this idea that we should add a start from here section for each repository, but we haven't yet added it. But to be clear, that part cannot be automated, because I guess it really depends on the repository that we have or the access of the files that you need to present to people. But that is actually a great idea, and that is a part of the future work that we want to do.